Okay guys, let's proceed to our next video, which is on inverse. Right, we have learned previously that the way to inverse 2 by 2 matrix is quite simple, which is by using 1 over determinant times with the this one, right, where we change the AD, negative B and negative C. Okay, and this formula being obtained based on these properties, right? These properties, but we are not going to discuss about that, right? So let's see on how to find the inverse if the matrix is more than 2 by 2. So 3 by 3 or higher matrix. Okay, we have two ways. The first one is by using cofactor methods, and the other one is by using elementary row operation, so which is known as ERO. So we are going to discuss it in a separate video. So let us look first at cofactor method. So for cofactor method, okay, the formula is this. Okay, you see A inverse equal to 1 over determinant times with the adjoint of that matrix. We have already learned all of this, right? We have learned on how to calculate for determinant when it is a higher matrix, and how to calculate for adjoint in the form of higher order matrix. So we are going to use all of that. Okay, so first example 2.26, let's see, find A inverse if it is invertible, given that A is this. So we have 3 by 3 matrix. Now before we proceed, right, we know that later we need to calculate for adjoint. So to calculate for adjoint, we'll first need to calculate for the minus, all of the minus for each elements and all of the cofactors, and then after that we transpose it to get the adjoint. If you don't remember how to do it, you can always refer to our previous video. Okay, but we're also going to do that later. Okay, however, before we go into that tedious process, finding the adjoint, it is better for us to answer this. Is this matrix invertible? So what is one way to determine whether it is invertible or not? If we know the value of determinant. So if we know that the value of determinant, which is not equal to 0, we know that it is invertible. If it is equal to 0, then it is not invertible or cannot be inverse. So let us first find it. So how to find the determinant for 3 by 3 or above? Okay, so of course one way for 3 by 3 we can use the idea of 2 by 2. However, we need to expand the first two column to the right hand side, if you can remember. Okay, but let us do the other way around, because later we are going to calculate for cofactor. So why not we just do that already? So to find the determinant for cofactor, for 3 by 3 matrix and above using a cofactor method, we are going to just sum the cofactor with times the element for one of the row or one of the column. Remember the formula? So one of the row and one of the column. Okay, so let us first choose which row or which columns that we want to calculate. So if there's any row and columns with a 0, a lot of 0, of course I will choose that. But as for this one, we'll see that there is no 0 value in one of the elements. So still, right, don't choose randomly, right? To make an easy way for us to calculate later, let us find an element that is, we find a row or column that contain a large value, okay, which is maybe this or this column, or this row or this column, right? Why we choose this? Because later in calculating the determinant, the minor for each of these elements, right? For example, for -4, this will be the calculation for the minor. For negative 6, this will be the calculation for the minor, and 15, this will be the calculation for its minor. So as you can see, they only involve small numbers, so it will is our calculation, right? If we choose maybe this, later will involve big numbers, so it might be a little bit complex for us to calculate. Not really complicated, but we just want to make things easy, right? So let us choose, let's say, the third column as our way to find determinant for this matrix, whether it is invisible or not, right? So let us input it. Alright, I have input everything. As you can see here, this is the column that I choose, which is 1, 3, 2, 3, and 3, 3. So this is the way for us to calculate the determinant by using the cofactor method, so which is the element of 1, 3 times with the cofactor of 1, 3, the element of 2, 3 times with its cofactor, plus the element of 3, 3 times with its cofactor. So this is the element. Now, for example, if I look at, I will just put it like this. Okay, so this is the element of A13, which is negative 4. Okay, and this is the calculation for C13, where you have this as the minor, right? If you can remember, negative 4, okay, this is the element, so the minor will be those outside its column and row, which is this. So 2 times 6 minus with negative 3 times negative 3. This is what I did here. So, and then negative I plus j, which is 1, 3. So negative 1 plus 3. All and all, this calculation gives us negative 12. Okay, and the next one is this. This is all the calculation for C23. Actually, A23 lah, for A23. So again, the minor for it is 1, negative 2, negative 3, and 6. Those outside its row and columns. So negative 1 times 6 minus negative 2 times negative 3. As you can see here, this calculation 1 times 6 minus with negative 2 negative 3 give us 0. So basically everything times with 0 will get 0. So that's why I just put 0 here. And as for the last one, which is the third elements, which is 15. Okay, this is in A33. Okay, so this is the calculation. I have 15 as the element times with its cofactor, which is this, right? So inside here is the minor for that particular element. So for this one, the minor is this 1 times negative 3 minus with negative 2 times 2, and that's give me 13, and that give me 15. So negative 12 plus 0 plus 15 is actually, sorry, not 13, 3. Okay, so 3. So basically the determinant for this equation is 3. So basically it is invertible, right? So because it is invertible, so meaning that we can find the inverse, we can proceed with finding the adjoint. So to find the adjoint, we have already figured out this, the C for this one. Okay, now we are left with another 6. So we need to find everything before we can find the adjoint. So let's do that. Alright, so to find the cofactor, to find the adjoint, we first need to look for the minor, and then cofactor. After that, we can be able to find the adjoint. Okay, so I have input it here. Now, so we still need to look at the original matrix. Okay, so C. So we have already find this just now. Okay, but remind, let's just look at it back. So for the first one, minor, right? So for A11, the minor is this. So negative 3 times 15, negative 45, minus with negative 36 will give us negative 9, right? So for this one, for A12, right? So those outside its row and column is 2, negative 6, negative 3, 15. Cross multiply and subtract, you'll get 12, and do that for each of the elements, and that will give us this minor. So for this minor, let us change it into cofactor. So as you know before, one way is to use, now this is the minor. Okay, to change it to cofactor, we need to consider the negative 1 I times I plus j. So as we did before, okay, for A13, it is negative 1 times 4. So when the negative 1 is in a positive form, right, it is actually will result a positive 1. Okay, when you try to just start to power it, 1 negative 1 times power 4, you will get the positive value. As for this one, 2 times 3, okay, which is this one at this area, you will get a negative value, negative 1. Okay, as for the last one, 3, which is 3 times plus 3, you will get an even number, 6, so it will be a positive value. Okay, and the same goes for other elements. So when you try to do everything, it have a pattern. So it's actually will be negative 1, and then this one will be negative 1, and then positive 1, this will be positive 1, and this will be negative 1. Just the negative and positive of 1, we still need to multiply them. Okay, so negative 9 times with positive 1, you will get it will remain negative 9. For this one, it will become negative 12. For this one, it will remain 3. As for this one, it will become negative 6 with negative 1, you get 6. 3 with positive 1 will remain 3. And then let me finish everything. So there you have it, the cofactor, right? Just changing the positive and negative based on negative 1i plus j. And after that, to find the adjoint, we're simply going to change the column to row or row to column. So let's try to change the column to row. Negative, we have here negative 9, 6, 0. Okay, then negative 12, 3, negative 2. After that, we have 301. 301. So this is the adjoint. After we have everything, the next thing to do is to substitute all of them in a formula of inverse. So we have the adjoint, we just input it in the formula of inverse, right? Let me do that, and there you have it, right? The formula, after you have substituted everything, first the determinant that we calculate before, which is this, which is 3, right? 1 over 3 times with the adjoint, which is all of this. So the next thing to do is just to multiply each of this element with 1 over 3. Just do it like scalar multiplication in matrix. Okay, so and you'll get the answer of, okay, and this is the answer. Right, so 1 over 3 times with negative 9, you'll get negative 3, and so on and so forth. So this is the inverse of our 3 by 3 matrix, right? This, okay, so that is how to do it through cofactor method. Okay, so you can try to do the exercise, but first please look whether it is invertible or not. If not, you're going to just waste your time finding the cofactor. Alright, so after this we have to talk about how to find the inverse by using ERO, right, which is quite interesting. Okay, thank you, bye.